Hello, this is Mrs. Taylor, and I'm going to show you how to write a piecewise function given a graph. So here we have the directions to write the piecewise defined function shown in each graph, and we have this graph here. I can see that it has three pieces, so that means that I'm going to have three separate expressions. And the other thing I notice immediately is that these units are not counting by 1. It seems to count by 2. So I need to keep that in mind when I'm determining things like y-intercept and coordinates of points. It's really important. All right, so when we are writing a function given a graph, we need to first determine what the function is going to look like. And these are all straight lines, so that means my functions are going to be linear, which means in the form of y equals mx plus b. With the exception of this line here in the middle, it's horizontal. And what we've learned in class is horizontal lines, they don't have x's. It's just y equals whatever the y value is that it passes through. And so I'm going to write the equation of each individual line first and put them all together in my piecewise function notation. And I'm going to start with the horizontal line because that's the easiest, because it passes through 2 on the y-axis. So that means the equation for it is y equals 2. And then I have the equation done. Okay, so let's move on to these that aren't so easy. What I'm looking at here is I see I have a negative slope, and it's not passing through the y-axis. I could extend it to see where it passes, but I need the slope first. So looking at two whole number coordinates, I have this point here, which is crossing the x-axis at -6. So this would be -6, 0. And then this point would be, this is -2. Halfway between would be -3, and then down -1. So this point would be -3, -1. And to find slope, I have two options. I can count rise over run. So I went up 1 over 1, 2, 3. Or I can use the slope formula, which is y2 minus y1 over x2 minus x1. However you'd like to do that. But if I use the slope formula, it would be -1 minus 0 on top and -3 minus -6 on the bottom. And then that would simplify to -1 over 3. So either way, I find out that my slope for this line is -1/3. Okay, and then the next piece of information I need is the y-intercept. So I could extend the line using this slope of -1/3 to see where it crosses. And if it crosses at a whole number, then I can use that whole number as my y-intercept. So down 1 over 1, 2, 3. Remember, these are counting by 2's. And so if I extend the line, just imagine it extended down 1 over 1, 2, 3. I see that it's going to cross the y-axis at -2. So that makes my y-intercept -2. And remember, in the y equals mx plus b form of the equation of a line, b is your y-intercept, m is your slope. So that's why I'm using b and m here. And so if I put those two numbers together in the equation for a straight line, it would be y equals -1/3 x minus 2. And so that would be the equation of this left piece here. And then using the same strategy for this piece on the right, I need a couple of points to help me count rise over run or to plug into the slope formula. And so this point here is at 1, 3. And then another point, let's pick this one. It's on a line here, and it's halfway between, which means it's a whole number because this scale is counting by 2. And so that point is at 2, and then 2, 4, 6, 7. So at 0.27. Okay, so now that I have some points, I can either count rise over run or I can use the slope formula. If I did rise over run, that'd be 1, 3, 4, so rise 4 over 1. Or if I use the slope formula, 3 minus 7, which would be negative 4, over 1 minus 2, which would be negative 1, and negative 4 over negative 1 reduces down to 4. So either way, you get a slope of 4. And then the next thing I need is my y-intercept. So if I extend the line, kind of pretend I'm extending it with the slope of 4, starting here, I would go down 1, 3, 4 over 1, and I see that it would cross this y-axis at negative 1. So that means my b value is negative 1. And so from there, it's pretty simple to create your equation. Just plug in m and b into y equals mx plus b. And so your result would be y equals 4x minus 1. And so that would be the equation of this right piece here. And this is a lot of information that I've put on this graph, so I'm going to kind of space things out here so that we can do the last part, which is to determine range. Because remember, with the piecewise function, each piece has its range given. And so domain. We need to find the domain. That's what I get for multitasking. To find domain, we need to look left to right. And the thing to remember is this is 3 pieces. So that means I'm going to have a left piece, a middle piece, and a right piece. And so the left piece is always going to be your less than, and your right piece is always going to be your greater than. And so this left piece travels all the way to negative 3. And so that means that my domain is going to be less than negative 3. And so I would just write x is less than negative 3. The one thing that I do have to keep in mind, though, is it an open or closed circle at negative 3? And when I look at this left piece here, it's a closed circle. So that means not only is it less than, but it needs to be less than or equal. So that would be the domain of my left piece of this graph. And then the middle piece, it travels between 2 y values. So that means that I'm going to have a compound inequality for that domain. And it travels left to right from negative 3 to positive 1. And so when I write that inequality, I know that it's negative 3, and I know that it's positive 1. And if I am using a compound inequality, I'm going to use less than for both, because if you write least to greatest, it's always going to be less than and less than. And the last thing to check for is open or closed circles. There are open circles at both negative 3 and positive 1, so I don't need the equal to's. And so that would be my domain. It shows very clearly that x is between negative 3 and 1 for this section of the graph. And then this last piece here, this is on the right, so this is my greater than piece. And it starts at x equals 1 and continues to the right. So that means it's going to be x is greater than 1. And it has a closed circle, so that would not only be greater than, but it would be x is greater than or equal to 1. So now I have my equations of each piece, and I have my domain for each piece. So I have everything I need to make my piecewise function. And so when I put it together, I use function notation, f of x, and then I need my brace. And then I would put each equation and domain into the 3 levels. And I always do left to right. You may see it written differently, but that's how I always write my piecewise functions. And so our leftmost piece here is the equation negative 1/3 x minus 2. You drop the y equals when you put it in function notation. And so I would need to put that into my equation. And then I also need to include the domain, which is x is less than or equal to negative 3. So I put a comma, I write the word if, and then I put x is less than or equal to negative 3. And then I move on to the middle piece, which is my horizontal line at y equals 2. So you drop the y in the equals, and it's just 2. And then I put if. And then for this one, I have this compound inequality. So negative 3 is less than x, which is also less than 1. And then my third piece, over here on the right, it's the equation y equals 4x minus 1. Drop the y equals, so just 4x minus 1, comma, if. And then include my domain, which this time is x is greater than or equal to 1. And so once I've got that all typed out, then I now have my piecewise defined function for this graph. And so it's lots of steps, but most of what you're doing is Algebra 1. Probably don't reach Algebra 2 material until we get to the domain and then also actually putting it together. So that's how you would write a piecewise defined function given a graph.